Hello, everybody, and my name is Arghya Kusum Das, and I am an assistant professor of computer science at University of Wisconsin-Platteville, and I am an advisory board member of Institute's Data Education Initiative. And in this talk, I am going to describe about Institute's AI education initiative, which we have recently started to spread high quality data and AI knowledge across the world. So, we are at the initial stage and we would like to share our development progress with the community, and that's the motivation behind this talk. So we have started with the machine learning course for software developers, and for this development process we have collaborated with many different industry partners like Facebook, Fractal, Fidelity, and IBM to gather the requirement and develop the course for machine learning for software developers, and mostly targeted towards the beginners. But that's just the beginning, and we have lots of many courses in the list. Now, so far this machine learning for software course developer is concerned. Our early adopter is University of Wisconsin-Platteville, where we are teaching the same material developed by Institute and our collaborators to teach machine learning and to spread the knowledge across the community. So here is the agenda of today's lecture, today's presentation. First, I will discuss a little bit about the current state of machine learning, where we are moving, where we are now, and then I will describe the expected learning outcomes from a developer's perspective. That is, when you are learning machine learning as a developer, what should be the ideal learning outcomes? Is it only mathematics, or is it only the modelings, or something else? Then I will briefly describe about Institute and its collaborative effort, followed by the course highlights, that how we are developing the course, what is the difference with all the existing machine learning courses and everything. And then I will show you a little bit of coding demo in a Jupyter Notebook format, and just to show you that how to develop a developer's mindset when you will work in a machine learning project. And then finally, I will discuss about our future goals and conclude our presentation there. So, current state of machine learning is it's cross-disciplinary, and it's not only restricted in STEM. So, AI and ML is kind of everywhere. For example, starting from the e-commerce, social media, automated vehicle, targeted advertisement, to personalized medicine, smart IoT devices, virtual assistant, financial analysis, weather prediction, everywhere, machine learning is kind of everywhere. So starting from the industry like Amazon, Facebook, Tesla, to the small industries also are using machine learning for their customer discovery process, for their business analytics, for sentiment analysis, for lots of different purposes. So, the machine learning curriculums need to be better. Now, better means here I'm telling it should be more software developer focused. It should be updated to fit the business needs. Not only the mathematics or not only the theoretical knowledge is enough anymore. So we need to update it to fit the business goals. So also we need to consider different types of machine learning project management. Lots of new machine learning projects and data analytics type of projects are coming in the industry. So how to manage all those things. So, and the final thing is the bottom line, it should be accessible by the people from different backgrounds, including the non-STEM people, because in the industry, we get the people from many different domains, including biology, including commerce, and including liberal arts, to do many different things. So all of them should have the knowledge of machine learning. So how to develop the curriculum for all these folks. So that's what our motivation. So the expected learning outcomes from a developer's perspective of machine learning is we need to focus mostly on coding. Then we need to know more about the KPIs or the key performance indicators for machine learning projects. Also, we have to focus on the machine learning project workflows also. So here, as I have told, ML is not only learning the theoretical model or the mathematics anymore. There are a lot more in an ML education. We need to understand the data, we need to understand the type of problem, and finally, we need to understand the customer's need, what the customer wants. So the efficient skill set that are very important in the machine learning domain is the efficient coding, the development techniques, as well as the project management techniques. So these things everyone should start learning from the basic level. So here are different types of KPIs that everyone should focus when they are handling or when they are working on a machine learning project. So the machine learning project must be capable to analyze large data set. Well, large data set means more knowledge is embedded in it. So you have to extract more, you should be able to handle more data set in your model so that you can extract more knowledge and you can make your model accurate. And also your model should be capable to extract more knowledge from less data. Of course, sometimes customers may come with their requirement like, well, we did not collect, do not have much legacy data set. We have started our data collection process from much later, but we need to hit the market. So how can you do that? Those things should also be a key performance indicator for machine learning. And of course, the accuracy improvement is the major factor. And on the other hand, but well, not only the accuracy, but also you have to take care of the robustness of the model. Well, sometimes it may happen like, well, we have a very nice model, but the model is working on one environment, but it is not working on another environment. For example, your model is really working great on some kind of CPU, but it is not totally tuned for GPU or not totally tuned for FPGAs or something like that, which is trending in the market. So at that time, your model will start performing very slow, and maybe even if it is giving more accuracy, it may not be appreciated from the industry perspective. So performance or less execution time is a big concern. So your model should be able to take advantage of different hardware acceleration, different software application, and all these different things. So as we can see regarding discussing about all these KPIs, there is a big shift to the coding of machine learning, how to code all these things. So, and well, another big thing is the price. Well, the machine learning if you just give more resources, maybe your model can start to perform really great. But how about the price? You have to take care of the performance to price also. The machine learning model should not take more space in the memory, or it should be space efficient. It should not consume too much of resources. So overall, improve the return on investment is the major KPI for machine learning. And in order to improve the return on investment, you have to know all the different things that I have just discussed. So in order to do all these things, in order to develop the machine learning project, we have to get a better understanding of the entire project workflow, and not only the foundation of the model. There are a lot more to it. So we basically need to focus on the improving the productivity. For example, like we have lots of different libraries, including pandas or including numpy. So how to use all the libraries rather than developing the process from scratch. That's one of the big thing. And how to make better use of the library, which library, because every day there are new libraries are coming into picture, are introduced, and then you are remaining with an exponential amount of choices. But how to select all those different things. Then the other thing in machine learning development process, that is trying out different things that is suitable for your data set. That's a big thing actually. So you may need to try out different models. You may need to try out different types of tools. Maybe because of their implementation, the model is not working. The similar model is not working pretty similarly. I mean, is not giving the appreciable accuracy when you switch the tool. So lots of different things you have to test while still being inside the CI/CD or continuous integration and continuous deployment pipeline. So for those things, you have to focus on the better coding for machine learning, and so that you can try out many different things with minimal amount of code changes. So the bottom line is the ML projects are not only about theoretical. In a course, you have to have proper balance between the theory as well as the development knowledge of coding and everything. Now, Institute has collaborated with multiple companies, including Facebook, Fractal, Fidelity, IBM, to gather the requirements and as well as developed several codes and the course to bring the next generation machine learning knowledge to the software developer community. So here is a brief description of Institute and its collaborative effort. We are collaborating with Open Power from a couple of years back, where we have taken big data and AI collaborative research and teaching initiatives with Open Power. And as a part of this collaboration, we are collaborating with many different companies to bring the knowledge to the community and improving the data science knowledge to the community. So overall, at Institute, our motivation is to bring the best quality data education to the community. So the data education is one big data problem that we are trying to solve. We are collaborating with many researchers in different parts of the world, including different companies like Facebook, Fractal, IBM, and all these. Also, we are collaborating with different academic institutions like TU Delft, PSI Switzerland, and Oregon, many other academic institutions to bring the best course to the community. Wherever there is some kind of development, we are trying to make it available to the community so that community can make better use of it. So here is the current course. This machine learning for software developer have been developed in collaboration with Facebook, Fractal, Fidelity, and IBM. We gathered the requirement from them and developed the codes and all the slides and everything, whatever knowledge is required for machine learning developers. So here is the little bit of course highlight. So here in this course, so this course is our initial course in machine learning, where we are focusing on the machine learning for beginners. That means we are not expecting you will have any prerequisite knowledge and all these things. So the university students who are aspiring to join machine learning industry or data industry overall, or if you are switching the career to machine learning, or if you are a project manager or team lead who does not have much knowledge of machine learning, but getting involved in machine learning project management, all of you are expected audience for this course. As I told, in this course, we are not expecting any prerequisites. So here we will give you the we will teach you about the starting from the Python basics to the NumPy basics to pandas and all the different tools that you can think of. We have developed the code in such a way so that you can easily learn the fundamental development concept of machine learning, and then you can select your tool pretty wisely to develop, to get involved in the development process. And when it comes to machine learning tool, we are developing the courses like we are teaching the community with scikit-learn, PyTorch, TensorFlow, and all the other different machine learning tools also, which are coming every day. So here the best part of the things is you will be learning with the code that are developed by the industry partner, and through these type of coding you will understand the basic workflow and the steps that are common in most machine learning project, and based on that you can start working in a project, and you can set up your project environment, and like all these things you can do. And not only that, you can get your hands dirty with the coding on Jupyter style notebook. Eventually, I will show a small demo of coding, how a machine learning code should look like and what we are doing. But anyway, you will also get the opportunity to get your hands dirty with machine learning coding. And also you will get the opportunity to be involved in the project tuned for your needs. For example, the machine learning project needs are really different. Some have the aspiration to work as machine learning developer, some have aspiration to work as machine learning project manager. So we have the setup for projects where you can join the project based on your needs. So, and also you can learn with lots of hands-on with pre-configured virtual machine and container, where all these virtual machines and containers are available at the Institute website. And those virtual machines and containers are actually specifically tuned for many different forms of hardware. So as you can see in this screenshot, we have a power machine, we have x86 container, we have virtual machine specifically tuned for different types of hardware. And also you can install this virtual machine to the real high performance cluster, including several power-based cluster that we have. And you can start learning on the real hardware infrastructure, which can give you better knowledge of machine learning. So at this point, now I'm going to show you a little bit of coding demo, where I'm going to show you a couple of codes implementing different types of machine learning model. And I will just show you how how to find the common part in machine learning and how to start working on that. And I'm pretty sure after seeing these a couple of code, you will get the idea, like, well, which part I should specifically focus on, what should be the machine learning workflow look like, and all these things. So let me go to here. So here, basically, we have all the codes available in the form of Google Colab notebook, as well as like Jupyter notebook, and everything is available for our students. So here, basically, as you can see, so this code is a simple example of a logistic regression with the scikit-learn tool. So here, basically, what we are doing, we have made our code, and we are going to teach you how to do that. We have made our code in such a way so that it can work with many different models. The similar code will work for many different models and for many different tools without much of the code change. So for example, in the first state, we are downloading the data, then we are just downloading the data here, then there should be an exploration phase involved in any machine learning project where you need to know about different data set. So here it is showing that phase. And after that, there is a scaling type of phase that are pretty common in all the machine learning project, because the attributes and everything may vary a lot in terms of range. And if you do not scale, many mathematical operation may start behaving erroneously. So there are many different types of scaling mechanism. You can select the scaling mechanism based on your need. So and after scaling, you may need to split the data into training and testing data set, and which is also pretty common in all the machine learning workflow in order to test the data, in order to do all these things. And so this part in one word is called data wrangling, like understand the data, explore the data set, and then standardize the data, scale the data, and then split them into training and testing data sets. So this data preparation or pre-processing is called the data wrangling phase. And these type of phases are pretty common in all the different machine learning pipelines. And this is our beginner's pipeline to get you started. But well, all these steps will be similar in all our courses. However, the code may get a little bit changed, although the motivation will be similar. So anyway, after splitting the model, then it comes to the training of the model. Now, since we have lots of different types of tools available, you can see, like, if we just use scikit-learn, once you will have the mathematical understanding, the basic mathematical understanding, the actual machine learning model implementation code is possibly a few lines of code. In the beginner's code, as you can see, the actual machine learning training code is taking only 1 or 2 lines of codes. Everything else is mostly like the data wrangling pipeline, which comes in common in the pipeline machine learning workflow. And then, of course, you need to do the prediction, and of course you have to do the evaluation and test data set and all these codes. So now, this is, and of course you have to do the confusion matrix. For confusion matrix or different types of prediction may vary. I mean, the evaluation may vary based on your need. You may use like precision, recall, and all the different things. So however, these steps are pretty similar for all the different tools. For example, here we have used scikit-learn. That's why the machine learning model is a little bit different over here, but this is a similar code with the machine learning with PyTorch. And as you can see, here also the steps are all same. And not only the steps, all the codes written here are also similar. Like download the data set and then explore the data set, scale the data set, split the data set into 2 different test sets and training sets, all these different things. Because of the Python's availability of libraries like pandas and numpy, we can use the similar piece of code for data wrangling for many different projects. And then the training the model part possibly will vary a little bit, since PyTorch, there you have to implement the logistic regression in this way. So this is possibly the main difference between the code. And once again, once you are fitting the model, everything is again same. The similar type of code pipeline is there. So once you will have the grasp on this coding pipeline, then it will be really easy for you to change the model and try out different things. And not only PyTorch, so scikit-learn, PyTorch, and not only that, even with TensorFlow, the code exactly looks same until it loading the data, exploring the data, scaling the data, and everything looks same. And then split the data also. And finally, the model training process is a little bit different because it is TensorFlow. So that's possibly the only part in the code that in the pipeline that is going to vary. So we are going to teach all these different types of coding practices, which are very much essential for machine learning, so that just keeping the entire software development code, make it reusable, and then plug and play with different types of machine learning algorithms. And not only that, but also at the same time, you can see, so this is the code for logistic regression. And now let me just open another code for another machine learning model, so that you can easily see that, well, it's not only about the logistic regression across the tools, but also it will be similar for different other models also. So I think my, oh, okay. So here is SVM with scikit-learn. So this is totally a different model. However, you will see that, well, the first part of the code and data wrangling and everything is just exactly same. Scaling the data and all the different things are same. Visualizing, splitting the data, everything is similar, but the only difference is just training the model. So we are going to teach you how to plug and play with different types of model, and which is exactly, I mean, by learning which you can easily understand how to make a CI/CD kind of continuous integration, continuous development pipeline for machine learning. So that's what we are doing at Onstitute. So we have lots of codes available for starting from beginners to the advanced level, and you can just get the coding for many different, for your purposes. So now here is so that was our coding illustration. Now, well, so that's how our goal for this thing is to, of course, developing multiple AI, ML, and deep learning curriculums together with many different universities and and all the universities and industrial organizations. But also we have a goal to create like ONNX model zoo for ML education. So ONNX is a very nice model zoo where you can find the codes and machine learning model with different types of tools using Caffe, using TensorFlow. However, for the educational purpose, we need to find the workflow so that it can easily instigate your curiosity and you can learn better. So that's what we are trying to do at Onstitute. Machine, and as I have shown you that we have already a lot of codes developed, so to be the part of this zoo. So as the course student, you will get access to all these coding modules and everything. So here is a simple model zoo for ML education. I have already explained the code, but here it is a slide. So for example, like here also we have, here is a screenshot for neural network type of implementation together with scikit-learn, PyTorch, and TensorFlow. And we are building, improving our code zoo, or the model zoo with many other different tools and different possible different models also. So not only these, and as I have showed, like this is a model, this is the logistic regression things. So basically what we are trying to do, we are going to teach you the fundamentals of the model, and then we are going to show you the right tool starting from the beginners level to the advanced level, how you can work on a machine learning project so that you really do not need to search over internet for some readily accessible code. After going through this process, you will be able to write your own code to prepare your own model without any hassle. So here is the conclusion for this presentation. So we will continue our collaboration with our industry and academia, and we will continue the collaboration with Open Power, of course. And well, we are very much open for collaboration. So collaboration for our AI, for our entire AI education initiative. So for example, the collaboration can be like course adoption for your university, or if you have some suggestion to improve our course or improve your own course in your university, or we can organize the workshops and hackathons, and also invited guest lectures, and all the different things are possible. Those are all in the roadmap of Institute's AI education initiative. So that's the presentation. And well, so now I am open for question. So, all right. So now let me show you. So if you do not have any questions, so let me show you a small demo, like how Institute works. So let's say this is, so you can go to so let me open a window, and here, sorry, yes, institute.herokuapp.com, and so you can just type it in, and then it will take you the Institute web page, and then there you can select the student, or if you're an instructor, then you can select if you want to adopt the course, or if you want to take this course, or if you want to educate your students or improve your course, or any type of consultancy, you can select instructor, but I am showing you the course only. So here it is, and then select the domain. Let's say this is our data science education initiative. So here it is, and then if you just click on this free or anywhere in here, and the course will be open. So you have to just log in with your account. It will take just a few seconds. It will just ask you for email ID and password, and that's it. And after that, you can start learning with these courses. So, well, we have several video lectures are available free of cost. And here, well, as I have told, we provide the Docker container as well as the virtual machines also. So here, if you just click, so if you are working with our virtual machine or our Docker container, from there you can easily go inside our Docker container to do the coding and hands-on, do the video lecture and the hands-on practices at the same time. So let's say this is where I have deployed. So I am in UW Platteville right now. So we have a server called io.uwplatt.edu where I have actually deployed an Institute container. So if I just connect here, it will give me the Jupyter notebook where you can simply start working on working with your code, and you can do the development process. So you can play and pause the video at any time and do the development for better learning. And well, instead of any server, you can develop, you can just install the virtual machines or the containers in your home laptop or desktop to make it working. So that's all about the small demo of Institute and how you can do enhance your machine learning knowledge. So here I am stopping the screen share, and now I am open for any question. All right. So if there is no question, then I would like to take this moment to thank all our collaborators from different industries, including Facebook, Fidelity, Fractal, and IBM. And also, I would like to thank Open Power community and Open Power Foundation for inviting me for this talk. And thanks to all the audience for attending this talk. Thank you.